This conference will now be recorded.
Very good evening, students. So we have
This conference will now be recorded.
very good evening, students. We have started discussions on various type of questions, basic as well as advanced questions on various topics from both 11 and 12 standards. So in this session, I'll discuss from kinematics. I'll pick up numerical as well as analytical question, which will help you to understand the concept better. And in fact, these questions, some way or other, were asked in various competitive exam as well as board exam, etc. So today's topic from kinematics, this is distance, displacement, speed, velocity, and average speed, average velocity related to that. So these are actually the broad topic will be kinematics. Okay, so the broad topic is kinematics, and under that these topics are coming subtopics. Okay, so we'll solve few numerical problems as well as we'll discuss some analytical questions. Let us start with this question. So this question says a body moves along the curved path of a quarter circle. Calculate the ratio of distance to the displacement. Look here, quarter circle means like this. Okay, this is quarter of a circle. Okay, so this is actually 45-degree angle. So if I say the radius of the circle, this is part of which is r. So this is also r. We have to find out the ratio, calculate the ratio of the distance to the displacement. So displacement will be, see, the linear distance or the shortest distance from, suppose it is going from A to B. So what is the displacement? Displacement will be the shortest distance, this one. We have to calculate that. And what is the distance covered? That is the curved path. So here if I say distance is d and displacement is s, look, the distance is 1/4 of the perimeter of the circle, 1/4. Okay, so this is with proper unit, it will be then pi r by 2. What about this one, this displacement? So this straight line will be the displacement AB. We have to find out the length of that AB path or AB distance. So how do we find out AB? This straight line, length of this straight line. We know this is actually is becoming a triangle, right? A right angle triangle. If I just draw it perpendicular. So here you look, how do I find out this? So this will be actually square root of r square, this one plus r square. So it will be root over 2r. Okay, so square root of 2r. So this is the displacement and this is distance. So if I take the ratio, then distance to displacement, this is pi r by 2 and displacement will be this. Okay, look, this r is this. See, I can strike them out. Pi can be written as 22 by 7 into 2 into 1 over root 2. This can be written further 11. So what I'm getting, 11 by 7 root 2. Look, this 11 by 7 root 2, this option third is the correct answer for this question. Okay, so we'll go to the next problem. So what is this problem saying? This is saying that three particles P, Q, and R are situated at a point A, at this particular point, on the circle of radius 10 meter. Three particles move along different paths. So all three particles starts from A, but they are moving in different path, and to reach where? To reach B. See, this P is going all the way here up to B. A, acha, okay, so PQR, R is moving this direction and Q is moving along this direction, this to this. Okay, fine. Now what is the question? Then the ratio of the distance traversed, by particle P and Q, distance, not the displacement. So distance covered by or traversed by P, if I denote this distance covered by P, traversed by P, so this will be found out from this, see, this whole length of this. So 3 by 3, so it will be 3/4 of the perimeter, 3/4 of perimeter, that is 2 pi r. Okay, so this two can cancel each other. I can write 3 pi r by 2. Okay, so this is the distance covered or traveled by P. Now Q is going like this. Okay, so what is its distance? See, it is simply r. This is also r plus r, 2r. Okay, now I have to find out the ratio. So dp by dq, 3 pi r by 2, this is 2r. R cancel each other, 3 pi by 4, 3 pi by 4. So which one is correct? Third option. Third option is the correct answer for this question. Now let us go to the next problem. Okay, this is not a problem, this is actually an analytical question. The question says if displacement of a particle is 0, the distance covered must be 0. This is not true. See, why? Suppose this is A, this is B point, and this is C point. A particle or a car is moving in a straight line A, B, C like this, and suppose it goes from A to C and then returns back to A. So in this case, displacement will be 0, but the distance traveled will not be 0. Okay, so that is why it must not be 0. Okay, so when the displacement is 0, see, let us see this third option. It cannot be 0. You might be thinking this is true. It cannot be 0. See, if displacement is 0, that means I can say that the motion has not yet started. Then also the displacement will be 0. So in that case, displacement and distance will be 0, both 0. It depends upon the particle. These are not true. So only option is this one may or may not be 0. So why it can be 0 even that, even when when there is a displacement 0, distance also can be 0 if the particle does not move from a particular point. Okay, suppose it was supposed to move from A, but it has not yet started, so that's why this is 0. All right, we'll go to the next problem. This is also analytical question. This is not this is just exactly the opposite question to the previous one. If the distance covered is 0, the displacement must be 0. Okay, it must be 0. Displacement means what? Change in the position. If the distance covered by the particle is 0, then automatically the change in the position will be 0. So that will be obviously 0. So this must be 0. Okay, displacement must be 0. Okay, now this question, sorry, yes. So what is this question saying? A man walks for some time t. A man walks for some time t with velocity v. In the due east, let me then draw the map over here. Okay, so this is north, this is south direction, this is east, and this is west. Okay, the question says a man walks for some time t with velocity v due east. Due east means exactly in the east direction. Let us say it goes up to here within time t. Then he walks some time t with velocity v the due north. So from here it goes like this. It goes due north. Okay, due north means exactly north direction. Okay, let me just take this as north direction. Okay, so this is due east and this is due north in t time. So during t time, during time t, see it goes due east with velocity v. That means what is the length? If I say this is O, this is A, this is say B. Okay, now if I connect to this, okay, let us connect this. Okay, you have to find out what is the average velocity. So this is, say, average velocity means displacement, total displacement. I can say average velocity is delta s by delta t, the time interval. Okay, so in this case we have to find out what is the average velocity. So what is change in the displacement or displacement, total displacement? It is actually from O to B. So the displacement will be O to B. So this distance I have to find out. But what is OA? OA is, see, V into T, because it moves with velocity V for time T, and AB length also will be V into T, because it is moving from A to B in time T with velocity V. Now what is the OB? Length of OB will be square root of V square T square plus V square T square. Okay, so from here what we get? square root v square t square. Okay, this is OB distance. So this is actually displacement. I have to find out what is the time interval. So this is t, this is t. So total 2t. So the average velocity will be root 2 v, sorry, not v square. Here it is coming out of square root. So both will be t, this divided by 2t. Okay, so like that, see this t goes up, we get this v by root 2. So option 4 will be the correct answer for this question. Okay, now let us find out this question. This is really very interesting. I am really excited to solve this question over here. See, the question says a drunk man, say a drunkard, is walking along a straight line road. A drunkard is walking. Okay, a drunkard man is walking along straight line. All right, he is walking along straight line. Now look the way he is walking. As you know, drunkard man cannot be steadily walking in the forward direction, right? So he will be stepping forward. Some step he will take forward direction, some step he will take in the backward direction. Look here, he takes 5 steps forward. So forward step, let us say fs. Okay, so he is taking 5 steps forward and backward steps, 3 backward steps. Okay, followed by again 5. So he is taking 5 steps forward and then comes back by 3 steps. Then again he takes 5 steps forward and come back, or take 3 steps backward, and so on. Each step, these are all 1 meter. And how much time it takes for each step? 1 second. 1 second for each step. Okay, time 1 second for each step. Okay. Now question is, see, there is, suppose this distance 11 meter. After 11 meter there is a pit or a ditch kind of this. Okay, after 11 meter there is a pit on the road 11 meters away from the starting point. From this starting point, once he reaches 11 meter, I think not after, yes, so just after 11, or it is said, okay, 11 meter away. That means when he reaches 11 meter, he will be falling into the ditch or this pit. Now the drunk man will fall into the pit after how much time? That you have to find out. So after how much time the drunk man will fall into the pit? 29 seconds, 31 seconds, 30 7 second, 21 second. What is the correct answer here? Okay, so let us try to solve it. So first of all, look, if I say first attempt, it consists of forward and backward both. Backward step and forward step both. Both steps are there. Okay, first attempt. Then second attempt, how much distance he is covering, we'll check. So by first attempt, it goes, actually it takes 5 steps. Okay, that means 5 meter. It goes 5 meter, 5 meter, and comes back by 3 meter. During first step, it actually covers 2 meter. Then second step, but how much time it takes during this first attempt? The time is actually 8 seconds, because 5 steps he takes. Okay, and each step takes 1 second, and then again 3 steps takes behind or backward. So that's how each attempt he is actually advancing by 2 meter, but he is taking time 8 seconds. So second attempt, what will be that? So second attempt is 2 meter. It will start from 2 meter. Okay, suppose this is 2 meter. So it starts from 2 meter, then it goes 2 to 7 and come back by 3. So it will be some 4 meter. Okay, second attempt, 7 minus 3 meter, that is 4 meter. Okay, then similarly third attempt, by the time he is actually at 4 meter from here. So third attempt is started from here. So this will go 4 to 9 and reverse by or backward step 3. So it will be actually 9 to 6. So third attempt will be 6 meter. So after third attempt, he will reach how much? 6 meter. Okay, 6 meter. Now he is suppose here at 6 meter. Now if he takes after third attempt, or third attempt means how much time elapses. So time, see, first attempt takes, so this is also third attempt also takes 8 seconds. So total 24 seconds already has been elapsed. Okay, now when he was at 6 meter and take 5 forward steps, as soon as he takes 5 forward steps, he will be here. Okay, he'll be here. He'll be here inside the ditch. Okay, so that means, fourth, by the fourth attempt comes, he will be here. All right, each attempt, how much time it takes? See, first attempt it takes 16, second attempt, sorry, 8 second, 16 second, and third attempt he will be reaching up to 6 meter, that is also taking 8. So these 3 into 8 plus one more forward step 5. Okay, so this will be actually 29 seconds. I hope you are understanding. So first attempt means both consisting of forward and backward displacements. Okay, and then take the references. Okay, so that's, this is the time 24 seconds. How much it takes? I'm sorry. So this is 29 second. So total, it will take 29 second to fall into the pit. Okay. So 29 second. All right. Okay. So we'll go to the next problem. This is another interesting problem. A particle moving in a straight line. It covers half the distance with the speed 12 meter per second. Okay. See, a particle moving in a straight line covers half the distance. Okay. Let me say this is total distance d. Half the distance is this way somewhere. Half the distance covered with speed. How much? 12 meter per second. Okay. The other half of the distance is covered in two equal time interval. Okay. That means, and that with the intervals, two equal time intervals with speed, this much meter per second and this much meter per second. We have to find out what is the average speed of the particle during this motion. Okay, let us try to solve this problem. So half of the distance traveled, that means d by 2, traveled by this much speed. Okay, the other half of the distance is traveled, so equal interval. But the speeds are given 4 meter per second, 7 meter per second. Okay, 7.5 meter per second. So we have to find out actually the average speed. So average speed means total distance. Okay, total distance by or total path length covered by total time interval. So average speed total path length divided by or total distance total time interval. Okay, so what is the path length? Total path length we know here. Okay, okay, let me just do it here. So suppose d1 plus, see, d1 plus, in fact I can do it here. So this is d by 2 plus d by 4 plus d by 4. This is actually total path length. I could have written d itself, doesn't matter. But the time interval, see, the other half of the distance is covered by two equal time intervals. So t1 and t2 are same. So let us say to t1. And here I have to find out what is the time. So this is 2t2 say, and this is t1. This is the one. So t1 is actually, see, the half of the distance d by 2 by v is the 12. meter per second. So I can actually use this here. Now look this too. These velocities are given. The distance is d by 4. We have to use d by 4, which is by d by 4. It reaches actually in equal time interval. D by 4 by v. V is actually this is equal to some, let us say, yeah, T2. This is T2, 1 T2. And okay, so another one is T2 itself. This will be D by 4 by 7.5, same time interval, equal time interval. Okay. Okay, let me just go to the next page to get some space. So the question was actually the distance covered, half of the distance is covered with speed 12. Okay. The other half of the distance is covered in two equal interval of time with speed different, average speed. So d by 4, here also d by 4, then d by half will come anyway, the same equal distance. Okay, so half of the distance is covered by this much speed and half of them is covered by this much speed. I can directly write this too over here. See, this d1 can be written as d by 12, sorry, d by 24, and this could be written as, say, individual by individual, so it will be d by this is 18 plus d by 30, so this is 0. Okay, so this, see, by this I can understand, so these d's are gone. Okay, so these are gone, so what will be there in the numerator? 1 by 2, 1 by 2, so that will be anyway 1 divided by 1 by, so average speed, so this is 1 divided by 1 over 24, 1 over 18, 1 over 30. Okay, so in fact if we do this, I'm sorry, this is not 80, this is 18. So So this is 24, right? 4 3, this is fine. So this is 60. Okay, so this will be actually 360 360. So 24, this will be actually 90. Okay, let me just multiply 90. So better multiply here 1 over 24, right? 1 over 18 plus 1 over 30, right? So multiply 360. So this will be 15. Here it will be 20, and here it will be 12. I don't know how much are the figures. Oh my God. So figures are very big, it seems. Okay, I think I'm doing some wrong calculation somewhere. Let me just do once again. See, I have d half plus d half. Okay. Okay, the times are, see, two equal intervals. This is where the thing is, two equal interval. Okay, two equal interval. This one. So t1, t2, let us say t1 is this one. So d by 2 into this 12, like divided by 12. So this will be 12 only, plus d by 4 into this. This is also okay. This is d by 18 plus d by 30. Okay, this will be 1, d will cancel each other, 1 over, okay, 1 over this. Oh, I was getting 1 over this. Let me see this, what is there. 27. No, this is no way. These are not equal intervals, it seems. Okay, let me not waste my time over here. I'll just come back. Somehow I'm getting lost in between. Okay, so let me just do this. A car travels a distance d on a straight road in 2 hours, then returns to the starting point in the next 3 hours. Its average speed. See, some distance d. It goes in 2 hours, okay, and come back in 3 hours. So it is actually total 5 hours. Okay, and distance traveled is 2d. So 2d by, so average speed will be 2d by 5 hours. Okay, so this is actually average speed. Okay, so this is the one. Oh, there was an option 0 actually. Okay, let us go to the next problem again. Okay, this is not a problem. The numerical ratio of displacement to the distance covered always. See, distance will be always greater or equals to displacement. This is what is the relation. So the ratio of the displacement to the distance. So ratio of the, so this is this thing. Okay, that means S by D will be always less or equal to, less than 1, less, equal to or less than 1. Okay, this is true actually. Option 3 will be the correct answer for this question. I'm sorry, this S by D will be, yes, less than 1. S by D, less or equal to 1. Okay, now let us see this question. A particle in straight line, in a straight line for 20, moves for 20 seconds with velocity this much. Then moves with velocity 4 meter per second for another 20 seconds. Finally moves with velocity 5 meter per second for 20 seconds. What is the average speed of the particle? See, 20 seconds, so I have to find out delta S by delta T. So total displacement happening in a straight line, he is moving, that's why distance and displacement will be the same. So 3 meters, so V1 T1, you can write here V1 T1 plus V2 T2, okay, and V3 T3 divided by T1 plus T2 plus T3, etc. like this. Okay, this is the way to do here. See, this is 20 second and 3 meter. 3 meter per second into 20, then 4 meter per second into 20 second, 4 into 20, then finally moves 5 meter per second for 5 meter per second for 20 second. And how much? So this will be 60 over here. Now we have to see 60 minutes here, 20 into 3, so 20 into 3, 20 into 3, so this can cancel. So I have got here, this is 3 meter, I'm sorry, this 3 meter, so 3 plus 4 plus 5 divided by 3, so this is 12, sorry, 4 meter per second. Option 2 will be the correct answer for this question. Okay, all right, so I think this is the last question for this session. Obviously I'll try once again the one I have left with. Select the incorrect statement from the following. Average velocity is the path length divided by time. See, average velocity, when we are saying, we have to say displacement, not path length. So this is not true. In general, average speed is greater than the magnitude of the average velocity. This is true. Magnitude of the, yes, that is true. A particle moving in a given direction with non-zero velocity can have zero speed. A particle moving in a given direction with a non-zero velocity can have zero. No, this is not true. Non-zero velocity means there will be displacement as well as distance. The magnitude of the average velocity is the average speed. Magnitude of the average velocity. This is also not true. If both of them are moving with uniform velocity and also in the same direction, same straight line path, then this could have been possible. So you know this 1, 3, 4. So option 3. These are wrong for this question. Okay. All right. Let us go to this question once again and try at least give some 2 minutes time over here. A particle moving in a straight line covers half of the distance d. Okay. So d half goes with speed 12 meter per second. Okay. Then the other half distance is traveled or covered in two equal time interval, with speed this much and this much respectively. The average speed of the particle during this motion. So d by half, see d by half and half of that, that means d by 4 distance. This much meter per second. Equal interval. Equal interval of time, distance is different. How come equal interval of time? So I can take, okay, I see. We can do one thing. We can just take the average velocity of the other half. Okay. So total distance d by 2. All right. Total distance d by 2, equal time interval with different speed. That means you know the time intervals, like say d by 4 by this plus d by 4 by 7.5. Okay, these are the time. So in this case, d by 2. Okay, so let us see. This is d by 2. Let us keep this as it is. D by 4 means 18. D by 18 plus this is d by 30. So this d will cancel each other. Okay, so 2, sorry, this is 1 over 2 into 180, 18 plus this. Okay, that was 90. So you know this will be 118 plus 130. This will give you to 95 plus 3, 8. So 8. So 90 goes up. 90 by 2 into 8. Okay, this will be 45 by 8. This is meter per second average speed for the other half. So I have to find out average speed, right? So this is now simple, I guess. Yeah, so earlier it was this much, 12 meter per second. Okay, 12 meter per second. Total distance covered is d by 2, and here also d by 2. This is 12 meter per second. Okay, so 12 meter. Time is actually d by 24. Here d by 2 into the average speed. Here we have got 45 by 8. This 8 goes here, 45 here, this is 4. I'm sorry, this I'll just do in the next class. Now I'll stop it here for today. So thank you for your patience. Bye for today.